In this lecture, we're going to zoom in on arrays of const char a little bit. And I want to show you something that we didn't have the tools to analyze yet, but now we do. You know that we can set up a const char array like this, and we can store in text information using string literals. We can loop through this array called student and print each student inside. And this is going to work like we expect. We're going to do a ranged based for loop here. We're going to be grabbing each student and printing them out, and they are going to show up on the console. This is nothing new so far. We have done something like this with our fortune teller app, and you already know this. But what I want to bring to your attention here is that it is impossible to go in and change one of those strings here. For example, if we want to change Daniel to Kenil, we could try to do something like this. The first thing I want you to see here is the syntax we are using to try and get in and modify stuff. We are grabbing the element at index 0, which is Daniel Gray here, and we are dereferencing. Why are we doing that? Because what we store really is a const char pointer. So to access something pointed to by that pointer, we will need to dereference. But remember that the string literal inside here is going to be expanded into an array of const chars. So we can use the angle bracket syntax here to access things inside. But it is an array of const char. So if we try to modify that, we will get a compiler error because you can't modify something that is constant. So this is something you need to be aware of. But we can set up a completely separate new student, call him Bob the Great, and replace that in the slot of Daniel Gray. And this is going to work. And this is something you might want to prevent from your students array. Okay, now we have the tools to prevent that. We can mark this array as an array of const pointer to const. And that means that we can't go through the pointers stored in this array to modify the data pointed to, but we can't also make the data point somewhere else. And this is going to be a compiler error if we change this students array to be const char pointer const. And we are going to hop over in Visual Studio Code and actually do this. Okay, here we are in our working folder. The current project is array of const pointer to const char, which is really the solution to our problem. We're going to grab our template files and put them in place. And we are going to open this in Visual Studio Code as we always do, open folder. We are going to grab our code here and put it in. It is an array of const char pointer. Inside we have the data. All these things here you already know, nothing really to explain here. And we can loop through the data and print it out. So we're going to bring up a terminal and we are going to build with GCC like we usually do. Let's bring this up. The build is going to be good, so we can go in and clear and run Rooster. And we're going to print our students here, Daniel Gray, all the way to Dave Mahoro here. Okay, now that we have this, let's try and change Daniel here to Kenil like we did in the slides. We can try to do something like this. We can dereference and say students and grab the first student, and that's going to grab this character array here. And we're going to try and change the first character to a K. Let's try to do that. And you see that Visual Studio Code is already complaining because we can't really do that. This array is going to expand into an array of const char. And if we try to modify even a single character in here, we're not going to be allowed to do that because that's a const char. I think we saw that in a previous lecture. This is going to be disallowed, and this may be what you want. But what I want to show you is that it is possible to set up a completely separate new student and replace that in the place of Daniel Gray here. And that may be something you would want to prevent. One way you can do that is set up the student like this. It's going to be a const char pointer. It's going to be called new student. Inside we're going to have Bob the Great. And what you can do is say student 0. And grab the first student because that's what we are interested in, and say equals new student. And you see that the compiler is not complaining here. Even if we want, we can print this out again. Let's copy the code to print here. We're going to go down and paste that in. Now if we print, we're not going to see Daniel Gray as the first student. We're going to see Bob the Great because we just replaced that N. This is the statement that is doing the magic here. We can try and build and make sure this is working as we expect. And we're going to clear and run Rooster. We're going to see that the first batch of output has Daniel Gray. The second batch of output has Bob the Great. So we have successfully replaced in a new student. If you want to prevent something like that, you might declare the array here to contain const pointer to const. And that's a kind of pointer you can't either go through to modify what is pointed to, but you can't also make it point somewhere else. We have learned about that in the last lecture, and we can do that to prevent this kind of thing if we don't want users to modify our students array. And it is super easy to do now that you know about const pointer to const. We can put a const after the star here, and at the moment we do that, this thing is going to be a compiler error because we can't make pointers inside this array point to other locations. And that's exactly what we are doing here. So we're going to get a compiler error here, and this might be something you would want to do. So we're going to comment this out and say that it is going to be a compiler error. And I am telling you about this here because now we know about different ways we can combine const and pointers to achieve whatever it is we want. In this case, we just used a const pointer to const to prevent users from modifying the data we have in here through this pointer, or even make the pointer point to other locations. And that might be something you'd want. You're really free to use these tools to suit whatever application design you are going for. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. The next one, we're going to learn about the relationship between pointers and array. Because so far you might have seen that these things have some similarities, and we're going to be learning about all that in the next lecture. Go ahead and finish up here and meet me there.